In this video, we'll be looking at inclusive events, which are pretty much the opposite of mutually exclusive events. The formula for finding these probabilities can be seen here. So the probability of A or B equals the probability of A plus the probability of B, and then minus the probability of A and B. Now, most of this should look pretty similar to what we saw in the last video. This whole first portion is all the same as the mutually exclusive formula. The difference is, remember that now there's overlap between events A and B. There are possibilities that are included in both of those probabilities. So the reason we have to include this new part, the minus P of A and B, is that this removes the overlap that otherwise would be counted twice, because it would be counted in this part of the equation, and it would also be counted in the P of B part of the equation. Just another reminder, this formula, like the mutually exclusive one, is for dealing with a single trial. So let's look at an example to see if we can kind of make some more sense of this. You roll a six-sided die. What is the probability that you roll an even number or a prime number? So first let's think, why is this inclusive? Why are the events even and prime inclusive? Well, let's list them out. If you think about the even numbers, those are 2, 4, and 6. If you think about the prime numbers that show up on a six-sided die, we have 2, 3, and 5. So we can see these are inclusive because we have this overlap here between the two outcomes. Both even and prime have the outcome of 2 in them, which means to calculate this probability, we'll have to use our slightly more complicated formula. Right? The probability that it's even or prime is going to be the probability that it's even plus the probability that it's prime minus the probability that it's both. So probability that's even is pretty easy to calculate. There are 1, 2, 3 successes out of 6 total options on a six-sided die. Probability that's prime, there are actually also 1, 2, 3 options out of those 6 total possibilities. And for even and prime, there's only one case that it's a 2. So that means there's 1 out of 6 probability that's even and prime. So we just add these up. 3 out of 6 plus 3 out of 6 is 6 out of 6. Minus 1 out of 6 gives us a total probability of 5 out of 6. Let's look at another example. A bag is filled with 10 strawberries, 8 red apples, 5 green apples, and 7 bananas. You pick one random piece of fruit out of the bag. What is the probability that you pick a red fruit or an apple? So first let's explain why these events are inclusive, the red fruit and apple event. Well, we can kind of break it down by saying, well, what's in each of these events? The red fruit has strawberries, and it has red apples. The apple event has red apples, and it has green apples. If we think about these two lists, we can see that in both events we have red apples. So there is overlap here again, which makes these events inclusive. That means when we're doing our calculation, we have to use our inclusive formula. So the probability that we get a red fruit or an apple is going to be the probability that we get a red fruit plus the probability that we get an apple minus the probability that we get something that is both a red fruit and an apple. Because again, we have to take away the overlap that is counted twice because it's in both of these. Well, the probability we get a red fruit, let's see, there's 10 plus 8 is 18, plus 5 is 23, plus 7 is 30 total fruit, and there are 10 plus 8 is 18 red fruit, so 18 out of 30. plus for apple, there are 8 plus 5, that's 13 apples out of 30 total fruit, minus, the only thing that's red and an apple are the red apples, so minus 8 out of 30. If we finish doing this calculation, 18 plus 13 is 31, minus 8 is 23 out of 30. So our probability of getting a fruit that is red or an apple is 23 out of 30.